Hello once again. In the last video, I've shown you a process which is used to convert decimal into binary, which is called continuous division. The process is done by repeating division until the quotient or the integer part of the quotient becomes zero, taking note of the remainder each time. The problem with this process is you cannot use the same division to convert values which are fractions. In fact, you are going to use addition. The next process or the next method which I'm going to show you will apply both for fractions and integers. It's called pick, mark, and subtract. Now, this is a very simple process. However, this requires you to familiarize yourself with the binary series. So it's advised that you memorize it first. So how do we summarize the process? So this is a repetition of pick, mark, and subtract. First, we lay out the binary series, okay, both for integers and fractions. Of course, we will start with integers. Pick the value in the table that is immediately lower to the value that you are going to convert. Immediately lower, not the next number that is smaller. Mark the value in the table as 1, and then subtract the marked value from the given until uh, the difference is 0. When the difference becomes 0, we mark the vacant squares of the table as 0 and join them in the normal order. This is not confusing because we are not going to divide them, or rather to concatenate them into the reverse order. So first we have to familiarize ourselves with the binary series. The first number in the binary series is 1. The second number is just a multiplication by 2. We'll just use an Excel formula to multiply the, the previous value by 2. We are going from the right to the left. We're just going to copy this. When do we stop? For example, in this case, we are converting the value 200, rather 512. We are going to stop until the value which is not greater, immediately lower. For example, than the value that is being converted. Like in this case, we are converting 536. We can no longer use 1024 because this is now greater than the value to be converted. So we can only stop at 512. Let us mark this table. Let's try 536. We do a pick, mark, and subtract. What do we pick? From among the values in the table, we are going to pick the nearest one, the highest number which is lesser than or equal to 536. In which case, we know that 512 is that value. Once we have picked the value, we mark it as 1 in the table. After which, we are going to deduct the value 512. We are going to deduct the value from 536. We are left with 24. We repeat the process. From the table, what is the nearest value which is not greater than 24? We cannot pick 256 because it's greater. 128 likewise is greater. 64 is greater. 32 is greater. 16 can be picked, so we mark it as 1. And then we subtract it from the value which is 24. So equals this minus that. We are left with 8. What value can we pick from the table such that it will not be greater than 8? So the next value is 8 in itself. We pick 8 and then we subtract it from the currently remaining value. And now we have reached 0. So we stop. We visit the table again and we mark the vacant squares as 0. So consequently, our resulting value is 10000111000, which is equal to our previous conversion. Okay, so this is our previous conversion. Incidentally, this is easier to convert because we can just multiply each number with its place value and then sum them together. Okay. For example, if we are going to use the sum formula, we will have 536. Okay. Let us do another example. Let us show another example. Shall we say we are going to convert the value 10,200 356. Okay. 10,356. Okay. We will improve our formula at this point because the problem with pick, mark, and subtract is we can have a very long worksheet because of the continuous subtraction. So we are going to improve our formula such that we don't have to go down to the bottom. We'll move this first and we'll start our number series, our binary series. That's 2. We just copy this until okay, we reach a value which is lesser than, we cannot use 131,072, so therefore we delete this. 65536 is greater than 10,000, so we also delete this. And this is also deleted because this is already bigger. And we delete this because this is bigger. Okay. What we will do is we will put an image. Uh, uh, we will compute the place values first, even though they are vacant. A vacant space in Excel, by the way, is considered to be 0. This is much. This is the preferred modern conversion method. What we'll do is we can close this in a table, and then we will sum. We will compute the place values by using the formula equals the place value times the mark that we do. And then we copy that formula there. Okay. So that we will have a continual sum. So this will be our sum or a running sum which starts at 0. Okay. And we'll have I hope you follow. We'll copy this and we'll have a running formula for subtraction which will subtract whatever the value is here. And we will mark this as red, okay, so that we can now start our pick, mark, and subtract. So we just sum all the place values here and we start our pick. So what is the next value we can pick from 10,356? Obviously, we cannot pick 4096 because there's a bigger value, which is 8192. So we pick this. Right away, we have 8192, and the deduction and the formula automatically computes the difference. We'll only look at the red one. So what we'll do is now pick the next number, which is greater than the red number. So 2164 is great. We can pick 2048. Okay, and then it automatically subtracts the sum of 8192 to 2048. So we have the red number, which is 116. We will pick the next number. We cannot pick 1024. Excuse me. We also cannot pick 512. We cannot pick 256. We cannot pick 128, but we can pick 64. We still have 52. So our next pick will obviously be 32, where we have 20. So we can pick 16, and we have 4, which tells us that we can pick 4. We now have 0, so therefore we convert. We now mark the vacant uh, squares with 0. So now we have the equivalent of 10,356. We do not have to double check because we know that they are already equal because of our running formula. So to demonstrate the process, let us do this again using a different value. So let's say we'll use a bigger value, 135,458. Okay, so we'll have 135,458. Let me enlarge this. Okay, so I'll go back to the right side of my screen to start generating as far as I can. No? Anyway, the binary series. I start with 1, and then we just multiply this with 2, and then I just copy this until the end here. Control B. So what do we have? We have this is 1 million, so we can erase this because it's bigger than 135,000. This is 500,000, so this is also bigger, so we delete this. So we now have 264,172. So now let me create the table. Okay, let me create the table which I will use for the pick, mark, and subtract process. Now again, I'm going to compute. This is this is the value, and then to be converted, let's mark this. Okay. Maybe we can change the color. Yes. And then our sum, place it here by the way. And then we write the formula that will compute the place value, that will multiply the place value times with the mark. And then we'll just copy this all through the out to the end. And then we'll sum this again. And then we'll subtract the sum from the value to be converted, and we'll mark this red so that it will be easy for us to identify. So the first task is to convert. By the way, we have surpassed now. We do not need 262,144. So we start here. Can we delete this? Yes, no, because it's bigger than 135,000. So this is our first mark 100,000. So we are left with 4,386. We will look for the next value. So obviously this will not, and we can pick 4096. We are left with 290. We look at the red one. For 290, we can pick 128. Okay. We have 162. We'll pick 64, and then we'll pick. Let me just enlarge this. Okay. You're left with 98. We can pick 32. We're left with 66. Now, if we'll not reach 0, we'll do this all over again because it means we have done something wrong. So we have done something wrong now. Let's erase this. 4386. So we have left because we haven't used 4096. 4096 should be our next bit. For 290, we should have 256. 256 should be our next bit. We have 34, so we can pick 32. And for 2, we are left with 2. So all the rest, the, the vacant squares, we mark with zeros. So we now have converted 135,458. I hope that clarifies everything. In the next video, I'm going to show you how to use this process to convert fractional values. And then later, we'll also compare it with the process of converting into floating point values. I hope you follow the process, and anyway, we'll repeat this in the next video using fractional numbers. Thanks for watching and bye for now.